All right. Welcome, everyone. Great to have you at our live Q&A today. We'll be talking about the recent PyTorch 2.8 release, focusing on PyTorch packaging, exploring the release of wheel variant support as a new experimental feature in our latest release. This feature is designed to improve the PyTorch install experience for users once it becomes generally available. I'm really pleased to introduce today our speakers, Charlie Marsh, Jonathan Dektiar, Ralf Gommers, and Eli Uriegas. I will introduce each. Charlie is the founder of Astral, whose tools like Rough, a Python linter, formatter, and code transformation tool, and UV, a next generation and project manager, have seen rapid adoption across open source and enterprise with over 100 million downloads per month. Jonathan has contributed to deep learning libraries, compilers, and frameworks since 2019. At NVIDIA, Jonathan helped design release mechanisms and solve packaging challenges for GPU-accelerated Python libraries. A founding force behind WheelNext, Jonathan actively works on proofs of concept, demos, and PEPs, Python enhancement proposals. Ralf is the CEO of technology at Quansight, a longtime maintainer of NumPy and SciPy with over 15 years in the scientific Python ecosystem. Ralf also maintains meson-python, created the Array API standard and pypackaging-native, and focuses on building sustainable open source communities. Eli is a staff software engineer at Meta and a key contributor to PyTorch projects. Eli focuses on improving the developer experience through infrastructure enhancements and the application of AI to developer tools, and is a maintainer of PyTorch's build and CI systems. As you have questions today on wheel variants, please drop them in the comments wherever you're viewing from throughout our conversation. And with that, I will turn it over to our panelists.
Thank you so much, Jennifer. So first and foremost, I want to thank everybody for being here. I think, this was a project that we're all super excited about in terms of being able to improve the packaging experience for PyTorch overall. And so I'm super excited for us to be able to talk about it. I think packaging has been somewhat of an experience that people have been okay with or frustrated with throughout PyTorch's lifecycle. And so, WheelNext is an initiative to, look at kind of the whole experience of Python packaging and try to improve that for users overall, especially for people who are using specialized hardware or things like that. So I'm going to pass it over to Jonathan to introduce the WheelNext initiative. Oh, Jonathan, I think you're muted.
Thanks, Eli. So WheelNext is an open source initiative that we like the pun of reinventing the wheel being the name of the Python packaging format. And we are working at evolving the packaging standards for the scientific ecosystem, the machine learning space and deep learning space mostly. There's a lot of participants across different industries, packages, frameworks, and companies, different tools. It's really a cross kind of an ecosystem type of initiative. And we added a few QR code if you're interested about this initiative. Today, we are 4 people to represent different perspectives, but I'd like to put a shout out. It's the work of many, many people to be able to present what we are doing today. So please send them a thank you whenever you can. These are the current projects that are helping us to redraw the lines of the Python packaging formats and to try to imagine the next generation of the wheel format and how it could look like. And these are the different companies that have been involved so far in the initiative. I'm going to transition to Ralf for the current experience of installing PyTorch today.
I think back to Eli, actually.
Oh, Eli?
Yeah, so I can go over this. In terms of installing PyTorch today, I think we've all been somewhat familiar with this modal that exists on the pytorch.org website. If you look at it closely, it seems a little innocuous in terms of, how to install things, but I think it comes with a little bit of assumptions around which accelerator you're using, what accelerator version you're trying to use. And so having to add on extra things like index URLs becomes mental load when you're actually trying to do the install experience for PyTorch itself. The next slide, please. And so when we're looking at things like, pyproject.toml, and it becomes a little bit inflexible in terms of the way that we can define extra indices and the way that we can define extra packages. So if you have to depend on a specific accelerator version, or if it depend on a specific software version of something, it becomes a little bit difficult in order to be able to specify that within your pyproject.toml. And so installing anything that depends on PyTorch becomes somewhat of a game of trying to track down which type of suffix standard that you're trying to use, which type of accelerator versions are supported on which types of projects. And so wheel variants are an attempt to actually go through and kind of break through the weeds of local hardware to be able to enable packages to be able to be aware of the hardware that you might have or the software that you might have locally to install the best fit of package. And so I'm going to pass it over to Ralf to talk about wheel variants and how they're structured and the technology behind it.
Right, thanks, Eli. Okay, so let me start with what you can do today for a package like PyTorch that produces wheels. They're up on PyPI. PyTorch also has its own index servers. Those wheels basically can express three things, like what Python interpreter is it for, what operating system is it for, and what CPU architecture is it for. And that's all encoded in the wheel file name. That's not enough. So as Eli said, like we have lots of accelerators, like you have multiple CUDA versions, you may have ROCm, TPUs, more exotic things. None of that can be expressed today. And this is why you basically, as a user, have to manage that yourself. So what we've been working on for the past 6 months with these folks and many more is how do we make this actually work, right? So how do we express all the things we need to be able to express? And I think when brainstorming about this, we quickly figured out there's a lot of things that you might need to say. That you might be able to say you're on an x86 processor, but you might want specific SIMD instructions. You have a CUDA GPU and you have CUDA installed, which version do you actually need based on your hardware and your driver. And then there's other things like OpenMP support, MPI support. It is not a super long list, but all these things are way too much to encode in static tags or in a file name of a wheel. So we came up with this kind of plugin system. We did many iterations over the past 6 months and ended up with PyTorch 2.8 as an experimental release, as well as UV, which Charlie will talk about in a sec. That basically attempts to do this all automatically to the extent possible. And so you can say UV pip install torch just works, does the right thing, whatever local hardware you have, standard or exotic. So we've been going on this for 6 months, and the slide here says proposed future PEP. So we actually, this is a first release, and in a few months, we'll propose this as a Python enhancement proposal, so that it ends up being a standard, so that it can be officially supported by UV, by pip, and by any other installer that follows standards. All right. With that, I think we're going to go over to Charlie to show us how it's actually done.
Thanks, everyone. I'll just share my screen real quick. Is it up? Is my screen being shared? Cool. Thank you. All right, so I'm going to give you a short demo of what it's like to install PyTorch, the PyTorch 2.8 experimental release with wheel variant support enabled. And in some ways, it'll be kind of a silly demo because really what we're trying to do is make things a lot simpler. So there's actually not that much work to do to install PyTorch with the wheel variant stuff. It should just work and give you the build that you expect based on whatever's going on in your machine. So in this context, I have I'm promoted into 2 different machines. And this machine on the left is CPU only, and the machine on the right has a GPU. It has just like a single T4 GPU. So you can see like if I run NVIDIA SMI over on the left, which is commonly run to figure out if your GPU is working or not. You can see I don't even have NVIDIA SMI over on the left. And then over here, I think the output will be kind of hard on this small tab, but you can see somewhere here, yeah, I've got a Tesla T4. So on the right, we have GPU. On the left, we have nothing. And what I did in advance is I installed the variant-enabled build of UV. All the stuff that we're talking about with variants here, we've been working hard on it, but it's still very experimental. And the next step for us is actually to start putting this forward for through the Python enhancement proposal or PEP process. So the work that we've done today with this PyTorch release and this corresponding UV release is still considered fairly experimental. So for now, we've put this behavior in a separate build of UV. UV is our Python package manager. If you've used pip before, UV could be seen as an alternative to pip and other tools. It lets you manage virtual environments, install dependencies. So here I'm just going to install what we call like the variant-enabled build of UV. And if I just check the version, it says, okay, I have the UV WheelNext build. So I've got the variant-enabled build of UV for now. Next thing we're going to do is we'll create a project. So I'm going to create like a Python 3.13 project that's just called project, somewhat confusingly. And I'll just run UV add torch. And the output's a little funky because my terminal is small to make the demo work. But what happened here is it sort of solved for torch and all its dependencies. And importantly, because torch is variant enabled in this build and the installer understands wheel variants, it did something that doesn't normally happen today, which is it looked at my machine and it tried to figure out if I had a GPU, and if so, like what different versions of torch and what different builds of torch could be supported. In this case, I actually don't have a GPU. The tab on the left is the CPU tab. So I installed torch, and if I import it, hopefully that might take a second. So hopefully if I run torch CUDA is available, it should say false because I don't have a GPU over here. I got the CPU only build of torch. Now over here on the right, I already installed the WheelNext build, so we're good of UV, so we're good to go. But again, we'll create a little project, go in, and then I'll just run UV add torch. And this time what I expect to see is I actually have like way more dependencies. It'll be clearer when it finishes. So not only did I get torch, right, but I got all these different NVIDIA CUDA libraries too. And I didn't actually do anything different, right? This is all just based on the state of my machine. But because torch is variant enabled and the installer is variant enabled, what happens is the installer, when it goes to install torch, looks and says, oh, torch actually has like builds for all different GPU architectures, has a CPU build, and my machine has CUDA installed, it has NVIDIA drivers. So I can use the CUDA-enabled version of Torch. So without doing anything differently, I get the Torch build that's basically optimal based on the hardware and the machine that I have set up. So like, again, if we run is available, hopefully we get true. Device name, we see the T4. So again, this is the experience that we're building towards, not just for Torch, but ideally for like everything that's built against Torch, all these other packages that have nothing to do with GPUs, but are maybe specialized in different ways. The goal is you shouldn't really have to think about which exact build of Torch should I be using based on my machine. The installer and the people who publish the package and the packaging ecosystem should be able to manage that complexity for you. So this is what we're working towards with variants. You should just be able to run UV add torch or UV pip install torch, or however you want to use UV to install torch. You should just tell UV, I want to install torch. And the packaging ecosystem should basically do the rest of the work to look at your machine, look at what's available, and give you the optimal build without having to worry about index URLs or anything like that. It's been a lot of work just to get to this demo, and we have a lot more work ahead of us. But it's a pretty cool milestone to be able to do this in a way that, in theory, if we're able to get the standard through, is fully aligned with standards and totally generalizable to all the different packages in the ecosystem.
Yeah, Charlie, this looks great. I want to have an understanding, like for users, how do they understand what UV is doing and kind of, you know, is there more debug logs that might be available for users to kind of like get a feel for how it's making these types of decisions?
Yes. I don't know if they'll fit on this screen. We can absolutely try. Let me
Maybe
let
if
me
you shut up one of the left window with the CPU, maybe they will. Yeah.
yeah,
perfect.
that's a good idea. Let me just like remove the environment, and I'll just run like UV sync with verbose logs. Let's see if that gives us anything interesting. Cool. So the thing that ends up happening is when we go to look at some of these packages, like if we're looking at PyTorch, for example, or in this case, I guess NVIDIA cuBLAS 12.9, blah, blah, blah. What ends up happening is UV goes and looks and sees that that package publishes a variants.json file. So this is a file that basically that encodes the metadata of all the different kinds of builds that are available for that package. I don't have that tab open, but like that file would say, okay, there's a build. Actually, that's maybe not maybe Torch would be a better example. For Torch, it would say, you know, if the person has, if we can detect CUDA on the system, then these different builds are compatible or whatnot. So for each package, we go and we fetch the information about all the different variants that are available. And in that file, it also tells us how to figure out whether those variants are supported on the machine. So there's kind of two parts to that. There's, you know, if CUDA is available, what build should I use? And then is CUDA available is the second question. And so we fetch the file, we get the metadata, and then we run a provider that's actually, it's just a Python package that's shipped, in this case by NVIDIA, that runs on my machine to detect what what versions of CUDA basically are supported or what GPUs are supported here. So the process is, it's similar to our standard dependency resolution process, but it's got this these additional steps injected, which are figure out all the different builds of PyTorch in this case that are available, figure out what's required, and then actually run Python code on our machine to figure out whether those requirements are met or not. So in this case, we have a bunch of caching, so the response isn't quite as interesting. But for example, all the providers in this case all the packages in this case need to figure out like what NVIDIA software we have available on our machine. And ultimately, because we detect that we do have a GPU installed, we can use, in this case, the PyTorch CUDA 12.9 build is compatible with our machine. So you'll see, like, you've probably seen, if you've done any work with PyTorch or spent time in the packaging ecosystem, you've probably seen a wheel file name before. And this part is the part that's already standardized and exists today. And ultimately, the thing that we're adding is this suffix at the end, which is this CUDA, in this case, CU129 is CUDA 12.9.
If we can switch to my screen for a second, I'll show you the JSON file. Sure.
I can also actually, I would have to open my screen. I would have to switch my screen too.
We could curl the JSON and
yeah,
that's true. I won't have JQ, will I?
Oh, so great. So let me zoom in. So the CUDA 12.9 tag that Charlie was talking about. So this is the JSON file that contains the description of essentially the variant installed. And we have the CUDA 12.9 tag that Charlie was talking about and the different description of what is it compatible with. So it's pretty simple in design, but just allows us to effectively do the resolution quickly.
You know, one question I do have, Jonathan, is kind of around, you know, we're talking about provider plugins and like how provider plugins work. Can you give a little bit of insight into how, you know, the specific NVIDIA provider plugin works and like how people can, you know, build their own or, you know, work on their own?
Sure. So a provider plugin by itself needs to comply with a fairly specific API that is very simple. It's a little class that essentially provides a few entry points, and it allows it to either dynamically or statically analyze the system and emit a number of flags, essentially. These flags are then matched against what is available on the index. summarized through the JSON file that we just shown. I'm gonna zoom in to make sure that it's visible. And so for the case of the NVIDIA variant plugin, which I'm gonna paste in the comment section, if anyone is curious, it's essentially just a little script that analyzes your system and emits a number of flags that we can then match against the current installer. So the flags have this kind of a triple tuple type of format. And currently the NVIDIA plugin support the CUDA UMD, so CUDA driver lower bound, upper bound, and SM architecture, which is the type of CPU that you have. And it's automatically installed. You don't really have to do anything. But if you wish to influence how the system is working, there are two environment variables that you can play with that are called NVVariant provider force CUDA driver and NVVariant provider force SM arch. Obviously, if you play with these variables, you might end up with a non-functional build for your system, but that should give you a good feeling of how these different things function and how they influence the system.
Yeah, I think I saw an interesting question, come through the comments, specifically around non-root users. The question is, will the non-root users be able to install the Torch package in their specific virtual environment with or without GPUs? Is there any privilege required for PIP to be able to find hardware details on the system? I think, Ralf, maybe you might be able to answer some of those questions.
All right, I'll give it a go. So it's an installer question, so Charlie can correct me if I'm wrong. I would say you still need the CUDA driver installed on your system, right? If it's, for example, for CUDA hardware. But anything else comes from PyPI or Wheels. So you don't need any more privileges than you would need for installing any other package to install wheel variants. The last bit is, depending on how the querying of your hardware is implemented, the installer may need to run some external tool. So the very simple, if you have a very simple implementation that just runs some other like executable, right, to say like, hey, do I have hardware feature X on my system, right? That executable needs to run, but that already happens because pip already knows, for example, as does UV, what kind of CPU you have. So, it's already able to do these things. So I wouldn't expect any other permissions for anything to be needed than you already have today.
As for now, we didn't find a use case that would require elevated permission, but it would be technically possible to think about a plugin that would require system level permission to query something on the system. Like low-level driver type of support, for example, or this kind of thing. For the case of PyTorch, this is not the case. User-level permission is perfectly sufficient.
Yeah,
and so far we don't have a use case for anything that requires root.
Yeah, and for anybody who might be asking, kind of the question around like what kind of platforms will be supported in the future, we kind of view all of the current platforms that PyTorch builds for around like ROCm and CUDA and CPU, and I think I saw a question about Intel, XPU, things like that. We kind of view this as being kind of where the future of these wheel variants will go, and we want provider plugins for all of these different platforms and architectures and things that we might work with. And so we're super excited to be able to eventually support that in the future. One question I do have, and maybe like a broader question around kind of the wider PyTorch ecosystem and around wheel variants just in general, is like, will VLLM, Flash Attention, all of these projects that somewhat depend on PyTorch or, even feed back into PyTorch, will they, need to adopt wheel variants as well? Like, what does that process kind of look like? I'm just looking towards the panel for anybody who wants to take a stab at this one.
Well, it would be awesome. Let me put it that way, right? They don't need to adopt it because the current way, which is non-variant, is still gonna function. But we hope that the benefit of using variant is so great that people will be convinced into switching to variant because it will make everything so much easier to install, especially these chain dependencies where essentially installing VLLM will chain install PyTorch for you. This is where variant kind of shines because it's very complicated to get a specific build of PyTorch if you don't install it first by installing VLLM. So variant should be able to resolve in a more dynamic all of these dependency chains. I don't know if somebody else has something else.
Yeah, I'd give it a slightly different answer. I think, yeah, it's not required, but it's, for the optimal experience, it's definitely going to be beneficial for people to align on using the same, building the same variants and, using the same variant provider, right? So I think in practice, there's, for example, if you have an NVIDIA GPU, there's going to just be an official NVIDIA plugin, and that's going to the thing everybody's going to rely on, but you don't have to. Right? But if everyone picks a different plugin, or half the people use it and half don't, and half use, CUDA 12 and half built for CUDA 13 only, right? Obviously, you cannot get a coherent stack, right? So if only half of the projects implement wheel variant support, nothing's going to get worse than today. It's still going to get better, right? But if you do pip install VLLM and you want VLLM and PyTorch to all be optimal, right? They are going to have to build the same sets of variants, roughly.
Yeah, and one thing I saw a question that came through around kind of like, benefits that we foresee beyond the PyTorch installation just working. I think a lot of people around PyTorch packaging have complained about things like binary size and, being able to find the right version. And so, one of the things that might be an interesting case study or an experiment with the wheel variants is being able to make architecture-specific installation. So instead of needing to download all of the architectures for all of the GPUs that we might support, you can download a specific architecture package for the GPU that you're working with locally, making binaries, a lot smaller than what we're observing today. And so, I think there's a lot of network benefits to kind of having, variants be able to give more information about your system to the installer to be able to install the best fitting package for your system. And I think, users will end up reaping the benefits of that through download sizes, through local storage sizes, through, being able to not have to think about, which package do I install when.
There's another benefit that today the ecosystem has not leaned into because it's too complicated to achieve. It's essentially right now when we build packages, I'm thinking about PyTorch, but I'm also thinking about NumPy, for example, scikit-learn. There's a lot of optimization that we could do that we are not doing, like activating special CPU instructions, for example. You have AVX on your CPU, great. You can use it, right? But the problem is because we have no way of detecting if you have AVX 512 support, we're not able to give you this. We have to build for the lowest common denominator, which means the least optimized way. Tomorrow, we'll be able to detect these type of CPU-specific features and consequently optimize and deliver better optimized packages for these specific use cases. Another example is macOS, right? There are differences between the M1 and the M4 CPU. Well, we could build specific version of these packages with specific ARM instructions that these CPUs include. Variants enable the more optimized way of building these artifacts and delivering more performance to people for free, because we don't have any additional cost of doing it. Doesn't make things more complex. Only at real time.
A great question just came through. Sean McGovern asked how much work would be involved for particular libraries like VLLM to adopt the wheel variant approach.
Who wants to take it?
I can take a stab at that. So I think there's two cases, right? One is packages already build different variants. They just host them elsewhere, like PyTorch does. And I think VLLM doesn't offer as many flavors today as PyTorch does, but they do offer some. If you have them already, there is tooling that actually Jonathan wrote to kind of repackage those wheels and just basically edit the metadata and change the wheel file name to make it wheel variant compliant. So going from, I already set up my builds to, well, now I have a wheel variant compliant thing that UV will understand. is very straightforward. The other thing that Eli was talking about is like, hey, I don't have them yet and I want to make them. Like, it's still extra work, right? Like if you want to build, architecture specific, smaller CUDA binaries, or you want to add SIMD instructions, as Jonathan said, you're going to still have to mess with compiler flags and so on. But that's the hard part, right? Making them wheel variant compliant is not hard.
Just to give an illustration to what Ralf was saying, repackaging PyTorch from a non-variant build to a variant build takes about 1.5 minutes. So we don't have to recompute the recompile PyTorch. So it's pretty simple. The longest is to figure out which variant you want to build.
I think a good question also came through, and maybe Charlie, you might want to take this since I know you worked on this for the UV enabled version of it, is what would happen if you only built a higher variant? For example, M2 plus, but no M1, would it drop to a source build or an error? I think this is kind of going along the null variant things that we had talked about at some point.
Yeah, so, I mean, obviously some of this behavior is configurable, as in some of it is kind of user experience of like using the installer and what you want to happen. Like obviously if you have source builds disabled, then we would never drop to a source build. In the Torch case, I believe what happens is, or the part of the goal, well, maybe one thing to mention, part of the goal here is that there's a big focus on backwards compatibility. So if you have an installer that actually doesn't support variants, ideally that would actually not break and would continue working even if it looked at an index that was or a project that was variant enabled. So even in the world with, this is a slight detour from your question, but even in the world with, where the Torch index is publishing all these variant enables wheels and this variants.json, the goal is that the installers that don't support variants would actually just fall back to basically the existing wheels. There's also this idea of publishing a null variant. Jonathan, do you want to explain the current state of the null variant? Because I know it's changed a little bit.
Yeah, so the null variant is essentially a fallback mechanism. So in case the idea of the null variant is to always be compatible with it. So think about it like the lowest common denominator for absolutely everybody.
In the PyTorch context, the null variant is the CPU wheel.
So it will depend package per package, right? If you think about an M processor, that would be M1, for example, where the others would be M2, M3, M4. The reason why we created this fallback mechanism, because the fallback could also be the non-variant wheel, right? But there is a difference between a non-variant and a fallback variant. When you need a fallback from variant, you already have valuable information, which is you're not compatible with any of the variants that are available. So you can make a better decision by not downloading stuff that you don't need because you're not compatible to. So let me take an example with PyTorch, for example. So the default non-variant build of PyTorch is CPU plus CUDA 12.8. If you don't specify anything and you just pip install PyTorch, that's what you get. If you are in the variant world and we found that you're not compatible with NVIDIA hardware, then why are we making you download NVIDIA dependencies? That doesn't make much sense. So the null variant essentially just default back to the CPU build only, because if we know that you're not compatible with any variant enabled build, then we know exactly what you're compatible with. And we can make a better decision consequently. So the null variant is kind of a second fallback way that some packages may adopt to take a different decision if we know that you're not compatible with variants due to hardware or software.
Yeah, another interesting question that popped up, I think Simon is talking about it. Hi, Simon. How can wheel variants help deal with the explosion of Python versions, CUDA versions? You know, some parts of a library are sensitive to CUDA versions, like CUDA kernels, and some parts can be sensitive to Python/PyTorch versions, you know, bindings. Like, are we thinking about this in terms of variants as well? Like, how can we help kind of with this explosion of Python versions times CUDA versions?
Well, you can take that one, Eli.
Yeah. I mean, I think it's something around, you know, helping ensure that we can have smaller, CUDA enabled packages. I talked about architecture specific ones as well. I think it's always going to be a thing, as we have to support more Python versions, as we have to support more CUDA versions, I think it becomes, a bit difficult to tell. One thing I will talk about, it's not related to wheel variants, but it is related to, PyTorch just in general, is we are working on a stable ABI for PyTorch for C++. And so, the amount of times you might need to upgrade PyTorch might reduce in the future. I know that the tensor portion of that stable ABI just came out, and so hopefully that makes it easier to maintain downstream packages like VLLM. And so our hope is in the future that we can help enable that. I'm not sure if wheel variants plays into reducing the matrices of things that we need to maintain, but I do think that stable ABIs might make it easier in the future to not have to upgrade every single time.
For matrices, wheel variant is not here to tell you what to do. It's here to give you the tools to be able to do what you want to achieve as a package maintainer. If you identify that a specific configuration is valuable for your user base and for the people that you support and you build your product for, then we want to give you the tools to essentially be able to build that product. If tomorrow the PyTorch team decide that a specific build of the matrix is important and want to support it, they will have the tools to be able to do that. So it's kind of up to each company, each project to be able to kind of decide for themselves. If NumPy wants to build 2,000 variants or just 5, well, that's on NumPy maintainers to draw the line where things are. And we have Ralf to be able to talk on NumPy, for example.
Yeah, I think we won't build fewer, right? So I think in practice, if you start using wheel variants effectively, you're probably going to have more wheels, but they're going to be a lot smaller and simpler to build, right? Because they're going to be more specific. And that problem isn't new. Like, way back when Apple had like PowerPC and Intel, right? We already had these fat binaries that contained both into one. And the trouble is you would have to pick on what architecture to build them. And then the other half you would essentially cross-compile, and you basically shipped it without testing. And if it was broken, you would never know until users started to complain. Right? If you make them more specific, they become easier to test and more robust. So I'm pretty optimistic in that respect.
Yeah, I guess leading into kind of maybe, somewhat of a question around when can we expect this? What timeline do you expect, or do we expect, for variant wheels to be available on PyPy? I know that some of the people in this room have dealt with, PEPs already, and, dealt with the Python Package Authority. Like, is there a timeline where people can expect this to be available on PyPy?
Ooh, that's a tough question.
I'm happy to take that.
All right.
Go for it, Charlie.
There's no timeline, and it may never even happen. Like, I think we have to be honest, which is this is a design, this is a proposal. So what's going to happen from here is like basically we've done a bunch of work over the past few months to take what were initially ideas and refine those, iterate on them, and try to prove the design changed a lot. And ultimately, we've tried to prove that the design can work for real packages for complex scenarios. And that's what we're focused on presenting here today. Is we built this prototype of the installer, of the spec, of the PyTorch builds, and we now have an experimental installer that can install PyTorch builds based on understanding your machine. What happens next is arguably harder, which is we now need to take those ideas and they have been discussed in the community before, but we'll now kind of bring them back and say, hey, look, we have these working prototypes that illustrate the design that we've been working on, and here's why we think it's important for the ecosystem. And that can take a lot of time to build that consensus. And it's even possible that we're not able to build consensus around those ideas, and we end up having to go back to the drawing board or find other ways to solve them. So, we view it as our job to advocate for users, whether they are people like package and library authors like Eli, maintainers, or people installing and using those packages. And we're trying to push that experience forward, and this is a way that we're trying to do it. Hopefully it will ultimately be standardized, and then we'll see these wheels on PyPI. But there's still a lot of work left to do, basically, between where we are right now and getting these wheels live.
Yeah, and kind of talking about, work that's been done recently. I know that you had an announcement, yesterday around kind of, Astral's new offering around, repos and a product there. One of the questions that I had about that one in particular is like, what optimized PyTorch builds will you be offering, within your new products? And like, can you give a little bit of context around what the announcement was yesterday for the group?
Yeah, definitely. So historically, we've at Astral have mostly built command line tooling. So we built like Ralf, TY, these static analysis tools, and then UV, which is our Python package manager. And we're now kind of expanding our scope. We just announced yesterday we're building a package registry called PYX. And the motivation for us in expanding from like command line tools to also like a server and a registry is really that there are lots of user problems that we haven't really been able to solve with like just a package manager that we think we could solve if we also had a server and if we could do basically more things. So one of the motivations there is, in the UV issue tracker, I basically spend a lot of time trying to help users, not just with PyTorch, but with this whole ecosystem of things that build around PyTorch. So like PyTorch, VLLM, Flash Attention, Deep Speed, like all these packages. And one of the things we want to do is actually just make it easier to install all those things, like install pre-built versions with compatible, consistent metadata, like that are compatible with each other, that are clearly built for known, well-defined hardware, that are built across a wide range of versions, Python versions. So like one of the things that we're doing with PYX, for example, is we have basically different indexes for different hardware, kind of similar to PyTorch, but they're not just limited to PyTorch. They also include lots of builds of other packages that are all kind of collated in one place with sort of like coherent, what I would say is coherent, consistent metadata. So you kind of point your installer at our registry, and then we can do detection of your hardware in a way that's not standardized like WheelNext, which is the downside, but it, hopefully helps users. We can kind of detect what hardware you have and then pull in from our registry builds of all those different things that we've kind of curated for you. So that's like one of the ways that we're trying to make the experience a little bit easier. That's sort of like, I view it as kind of like parallel to WheelNext. Like WheelNext is us trying to push everything forward in standards. And at the same time, we're also kind of trying to make life easier for people without changing standards as much as we can, and without, I guess, deviating from standards. So those are like the constraints we put on ourselves is, we want to keep pushing things with standards, but we're also trying to make the experience better for people today. And the other nice thing about having our own registry is, if wheel variants are approved, we could be, we can have early support for that and be a place to also a place to continue experimenting with wheel variant support as we build it out.
Yeah. Thank you so much. We're super excited to see, what PYX has to offer and like how that can improve the, packaging experience in parallel with WheelNext, and how we can kind of like push the Python user experience forward together as a group. I wanted to, do a call out. I think everybody in this room wrote a blog about, the experience with wheel variants, kind of going into the more technical, gory details of how, variants work, how they work for different, installers. If you would I would love for people to come and check it out and, get a sense on how we can use them, how to do all those things. And to remind everybody, this is an experiment. Wheel variants is an experiment that we want to try. We're still working out the UX. A PEP has not been posted yet. We're trying to figure out kind of all the details of, how to make this as user-friendly as possible. I think each of these blogs includes instructions on how to use variants. If you're particularly interested, we have a blog on the PyTorch blog as well called PyTorch Wheel Variants, the Frontier of Python Packaging, that includes some installation instructions. And so, yeah, we want people to try it out. We need feedback about the experiences that people have. If you have any rough edges, please let us know. We're going to be setting up an issue tracker on the PyTorch repository. So if you have any issues that you run into, please let us know. So yeah.
Yeah, so we have a call to action. It should be pretty simple. The commands to try it yourself are displayed on the screen. If you have any comments, things that you would like to see, if you have any questions, if you have any issues, bugs, we want to hear about it. That would be absolutely awesome. That's thanks to community feedback that we can improve how things are being built and then consequently propose as a standard to the community. So we try to make it as simple as possible for people. So should be just a few lines in your terminal. Please try it, see how you like it. We hope that you like it and give us feedback on the overall experience. Feel free to tag any of us in the GitHub issue so that we can pay attention to it. And we look forward to see a more variant-enabled world.
Yeah, and Jennifer, do you wanna wrap us up?
You're muted.
You're
Jennifer.
muted.
Oh, classic. Thank you so much, everyone. That was a really interesting discussion. Thank you, Charlie, Jonathan, Ralph, and Eli. Really good discussion today. And thank you, everyone who tuned in. Stay tuned. Subscribe to the PyTorch newsletter to be updated about upcoming events and what we have going on. Follow us on social media. And then, as everyone mentioned, there's some great blogs out there. Be sure to check those out, too. Thanks for joining us.
Thank you.
Thanks, everyone.
Thank you so much.